The topic is Rabin-Karp algorithm. It's a pattern matching algorithm or string matching algorithm. The problem is, if a text is given and a pattern is given, then we have to find out whether this pattern is present in this string or not, or text or not. There are various algorithms for string matching or pattern matching. This is one of the pattern matching algorithm. Let us see how it works. First, I will discuss the basic idea of Rabin-Karp algorithm and what is the worst case of Rabin-Karp algorithm, then how to improve the worst case, and finally we'll see the actual algorithm. Let us start. See, this is a text given and this is the pattern we have to find out. So you can see that AAB is here, existing here inside the text. Then how do you check? We know the basic algorithm in which we will start comparing the alphabets. Here we don't want to compare each and every alphabet. So if you take a pattern, there are 3 alphabets. So instead of checking each and every alphabet, can't we make it as a single value? How we can make it as a single value? So we can convert this into some numeric value. Let us see how it is possible. See, if the letters, if I take A, B, C alphabets, then for the alphabets there are ASCII codes like small a, lowercase a is 97. So we can use that number. Okay, we will use that number. But if I use that number and explain you, then the numbers will be bigger. So to take small numbers, just to understand the algorithm, instead of 97, I'll give my own codes. A, let it be 1, and B as 2, and C as 3, D as 4, and so on. So I have given codes for all the alphabets from A to J. 10 alphabets I have taken. If you want, you can take ASCII codes also, but this will be simple for discussing the topic. Now here is a pattern. Now using those codes, we will try to find out a single value for this pattern. So I will use those values. This is 1 and this is also 1 and this is 2. I will add these values. This is 4. Even if you want, you can multiply also, that is your wish. I have added these values. So now whatever the value I got, this I will call it as hash code. And the procedure of getting that value, that is the function, we will call it as hash function of this pattern. P, let us say P is the pattern. So we call this as a hash function. We are using hash function and finding value of a hash function. Now this hash function, we use it for finding this pattern inside this text. So how to do that? See, as the size of this one is a 3, so let us say M is size is 3 and the size of this one is N and this is 6. Now how to check this? So I will take 3 letters, that is depending on the size of this pattern, 3 letters. And what are their codes? 1 plus 1 plus 1. And this is 3. But see, this is hash function value is 4. And there it is 3. It means they are not matching. I don't have to check the characters. Just I have used a function. Function means it will take constant time. So using constant time, I found out the value. And it is 3 and this is 4. They are not matching. So this pattern is not there. Then slide to the next set of 3 alphabets. So I'll remove this and I will extend this one, plus this is also 1. So this is 3. Now again this is not matching. So take out this, slide next. Now this is again 3 and 3 is not matching with this one. Means these 3 letters are not forming this pattern. Now slide next. See, this sliding is called as rolling hash function. From the present value, I am getting the next value. So that is called as rolling hash function. We will see it further. I'll include this one. So the code for this one is 2. So this is 4. They are matching. Once you get a match, confirm really this pattern is there or not. So now check the alphabets. These are A and these are also A. These are B. Yes, they are same. So pattern is found from index 4 to index 6 in the main string, that is text. So this is the basic idea of Rabin-Karp algorithm. I will take one more example and show you quickly. I have taken one more example. Let us quickly look at this example. Here we will understand what does it mean by rolling hash function. Let us see. There's a text given here and there's a pattern. First find out the hash value for this one. So the codes are B is 2, and C is 3, so it's 3 plus 3, and E is 5. This is 10. See, remember, I am showing you just the basic idea. I am not showing you the actual algorithm. Remember this one. Now, we have to find out whether this is present here or not. So, just take first 3 alphabets because this size is a 3. So, first 3 alphabets, this is 1 plus 2 plus 3. This is 6. And this is not matching with this one. Then, just slide it and get the code, hash code for next 3 letters. So, for that, from 6, this is 6, right? So, from 6, subtract this 1. So, we get 5. So, subtract this. And plus, what is the code for this? 4. Add 4. So, this is 9. So, in this way, the letter that we are skipping, we can subtract its code, and the letter that we are adding, we can add this code. So, in this way, we can get the hash function or hash code for the next set of characters easily in constant time. Now, 4. So, total is how much? This is 9. And 9 is not matching with this one. So, okay, take out this alphabet and take this alphabet. So, this is 1. Now, how much this is? 8. 8 is not matching with this one. So, this is not a pattern. Then, take out this and add 2. Now, this is 7 and 7 is not matching with a 10. So, take out this D and include C. So, the code for C is 3. This is again 6. 6 is not matching with 10. So, subtract 1 from this and this is 5. So, this is 10 and 10 is matching with this. So, it means there is a pattern. There is a possibility of pattern. So, verify it. B, they are matching. C, they are matching, and E, they are matching. So, yes, there is a pattern available in a string. So, this is the basic idea I have given you. Now, I will show you the drawback of this method. Then afterwards, I will show you actual algorithm. So, in the previous 2 examples, we were going through the main string only once, and at only one time we have checked for the pattern. So, we have gone through entire string only once, scanned through the whole string, and we have checked for the pattern only once. So, the time we say it was n minus m plus 1. This is the average time of Rabin-Karp algorithm. Now, let us see the worst case for this one. So, I have taken an example here and let us look at worst case. I have taken a string of size length is 11 and the pattern of length is 3. Now, let us find out the hash code for this one. By same method, just take the codes 4 plus B is 2 plus A is 1. From there, I am writing. So, this is 7. Now, the hash code, simple thing I have taken, that is 7. Now, let us understand the drawback. First, take 3 letters from here. C is 3 and C is 3 plus A is 1. This is 7. 7 matching. Compare the alphabets. D. No, this is not same. This is not same. So, means though we got a match in hash code values, but the string is not matching. Okay, go to the next. Take next 3. So, this is 3 plus A is 1, then this is 3. Again 7. There is a match. So, it means this pattern would be there here. Possibility of pattern there. So, compare this. C and D. No, they are not matching. So, no, it's not a pattern. Then take next 3. A is 1, C is 3 and C is 3. Again 7. Again it is matching. But this is not a pattern. After comparison, we'll know that it's not a pattern. See, we have got 3 matchings so far, right? 3 matchings, but those are not patterns. So, in this way, we are comparing this pattern every time. In our example, though we are checking only one alphabet, but in some cases, we'll be checking most of the alphabets and it is not matching at the end. So, let us continue. CAA here I will take. This is 3 and this is 1 plus 1. This is 5 and this is 7. They are not matching. Okay. Next, this is 5. They are matching again. And compare this. See, this is 7. This is 7. But check whether the pattern is there. No, pattern is not there. So we are getting every time hash code that is matching with the hash code of this one. This is the drawback. So if you take such a simple hash function, then there is a possibility of collision with the other pattern, other substrings which are having the same code, though they are not the patterns. So the drawback here is that there are many hash codes that are matching, but those are not the patterns. So actually these are called as spurious hits. So these are called as spurious hits. Means the matching is there with the code, but those are not patterns. So these are waste hits. This is the drawback. And in such a situation, the maximum time taken by this algorithm may be mn, theta of mn. This could be the maximum time. But we expect the algorithm to take n minus m plus 1 time. This will happen if there are no spurious hits. So how to avoid spurious hits? So this is because of the hash function. We selected a very simple hash function because of which these hits are happening. To avoid this spurious hits, we have to take a strong hash function. So what is the idea of hash function given by Rabin-Karp? So now this we will be completing the algorithm now. So I will show you the actual hash function that is suggested by Rabin-Karp. Now through an example only, the same example I will show you. See here the codes are, this is code 4 and this is code 2 and this is 1. So let us take it like this. 4 into 10 square plus 2 into 10 power 1 plus this is 1 into 10 power 0. Why power 2, power 1, power 0? Because there are 3 letters only in the pattern. So start from 0, 1, 2. So if there are 5 letters in a pattern, then 0, 1, 2, 3, 4. So highest power we can get 4. So if there are m letters in a pattern, then each letter of a pattern P1 into 10 to the power of m minus 1 plus P2 into 10 to the power of m minus 2 plus P3 into 10 to the power of m minus 3 goes on. So that same thing we have done 3. So first one is 3 minus 1, then 3 minus 2, then 3 minus 3, that is 0. This is how we will multiply these codes with this powers. Then what is this 10? This is the base value. How many alphabets I am using? 10 alphabets I am using. So I have taken that as a base value. You can use any value you like. This is just the idea given by Rabin-Karp. Hash function means if you know about hashing, you can define your own function depending on the patterns or the text that you are using. But for the alphabets, like for a string, they have suggested this method. So if I consider all English alphabets, then for 26 alphabets, I should take it as 26 power 2, 26 power 1, 26 power 0. If I say lowercase, uppercase, all special characters, everything, then total ASCII codes are 127. So this should be 127 power 2, 127 power 1 and 0. So to make our example simple, I have taken only 10 alphabets. That's the reason I am writing 10 here. Now let us find out its value. So this is 400 plus 20 plus 1. This is 421. So the hash code for this one is 421. Now using this code, we'll try to find out a match. See, just now for the same example, this was a drawback we found out. That is the worst case we found out because of the hash function. Now I modified the hash function, that is I have taken the one suggested by Rabin-Karp, and there is one more thing that I have to include it at the end. I will show you. Now let us find out how much this is. This is 3 into 10 to the power of 2 plus this is also 3 into 10 to the power of 1 plus this is 1 into 10 to the power of 0. So this will be 300 plus 30 plus 1. So 331. This is 331. Is it a match? No, it is not matching. The code that we got is 421. I'll write down here. Right? It's not matching. See, this is not a spurious hit because we have changed the hash function. So now it is not matching. Now I have told you about the rolling hash function. See, so many powers and everything we are taking, I have to calculate the next one. So what to do? So from 331, see, I'll just remove this. Now I have to find out the hash code for next three alphabets, these three. These three means what this should be, 3 into 10 square it should be. Then this should be 1 into 10, not power 0, power 1. So it means I should multiply these two into 10. So what I can do is I will take this as it is. I'll take this as it is and multiply it by 10 outside. Then I have to remove this one. And also I should include C. So overall, how to do this? Let me show you how to do this. This entire thing was 3 into 10 square plus 3 into 10 power 1 plus 1 into 10 square. So this actually is 331. So from this subtract this 3 into 10 square. So 3 into 10 square is subtracted. So this term will be gone. If I subtract it, this will be gone. So this portion will be remaining. So this entire thing multiplied by 10. So these numbers will be raised by 10, right? So this becomes 10 square and this becomes 10 power 1. Now I have to include this C also. So plus C code is what? 3 into 10 power 0. So how we do this? See, actually this is 331. So what we do is from 331 we subtract this first term and multiply the result by 10 and get the next term added. So you can just observe this carefully how this is happening. So this is the result as it is. This should be subtracted. Okay, subtracted. Then these two should be multiplied by 10. So the result is multiplied by 10 and this term should be added. C should be added. So C term is added. So I'll directly do that. Right now I am having the hash code for these three alphabets, that is 331. Now I have to get this for these three alphabets. So subtract this one, minus 3 into 10 square. So this is how much? 331 minus 300. So this is 31. Then to that 31, this portion I got, that is 31. That 31 I should multiply it by 10. So this 31 multiplied by 10. So I get 310. So this is gone. Now for this C, I should add this 3 into 10 to the power of 0. It means just 3. So in this plus 3. So this is 313. This is the method of getting the hash code for the next set of characters using rolling hash function. So once you got one function, then from there only subtract, multiply and then add, you get the hash code for next set of characters. So this is 313. Is it matching with 421? No, this is not a match. So there is no spurious hit. Let me continue for some more time so that if I calculate more, you can get the idea. This is a 313. I have to subtract this one. I have to remove this. So subtract this 3 into 10 square. So that will be 300 is subtracted. Okay, this is gone. Then these two terms I should multiply by 10. So result is how much? 13. 13 should be multiplied by 10. So I get the result for this 10 square and this is 10 power 1. Now I should include this one more alphabet. So its value I should add. So this is 3. So 3 into 10 to the power of 0. So in this I should add 3 plus 3. So how much this is? How much this is? This is 130 plus 3. It is 133. Now this is not matching with 421. So this is the hash code for these three alphabets. I'll continue. The hash code for these three alphabets is 133. Now I have to remove this one. So this first term should be subtracted. So this is 1 into 10 square. So this is 100. 100 is subtracted. So this is 33. So I got this remaining part, right? The remaining part. Now I should raise it to square and raise it to 10 power 1. So multiplied by 10. So we get 330. Now I should include one more alphabet, that is A. So this is plus 1 into 10 to the power of 0. So that is 1 only. So this is 331. Is it matching? No, this is not matching. Now let us calculate for next 3. So for that I should remove this first alphabet. So 3 into 10 square, 300 I should subtract from here. So from 331, I should subtract 300. So this is subtracted. So I get 31. Now 31 should be multiplied by 10. So this becomes square and this becomes 1. I should include one more alphabet. So this is 1 into 10 to the power of 0. So this is 1. So this becomes how much? 310 plus 1. So this is 311. This is not matching. So in this way you can continue at one point D, B, A. For these three we get the same answer, that is 421. And that time when there is a match, then compare, confirm whether it is the same thing or not. That's it. This is the method. So you may have to observe this little carefully so that you should be able to do these calculations by yourself. So I have given you the basic idea, then I have shown you the drawback. The reason of drawback was bad function. So I have introduced a better function that is actually given by Rabin-Karp. So this function is a rolling hash function, as well as they have given this that base powers we should take. So this is called as Rabin fingerprint function. So now there are no spurious hits. So the time taken by this algorithm is theta of n minus m plus 1 in average case. But still, though you have defined such a hash function, still there may be a possibility that there is a spurious hit. So still the worst case time of this algorithm is mn. Though by using this hash function we are reducing the chances of worst case, nothing else. Now one last thing that I have to tell about this one. See, when we are taking the powers of this, we may be getting a very large value. Now if you are getting a very large value and when you have written a program for this one, then it depends on the size of the data type. Like if you take integer 4 bytes, it may be exceeding the capacity of 4 bytes. So if it is exceeding, the number will overflow. If you want to avoid overflow, then you can mod these large values. You can perform mod upon these large values. So this entire function we can perform mod. With what value we should perform? It depends what is the maximum size of your data type. If it is a 32-bit data type, then you can mod it by 2 power 31. Like if it is 32-bit, then 1 bit is sign bit, 31 we take. So I am taking that 31. If you say no, it is only positive, then you take 32. It depends on the language you are selecting. It depends on the data type you are selecting. So for getting the result of this hash function, if you believe that that may be exceeding the capacity of the variable, that is data type, then you can mod it with that one. So that you make sure that you get the values in between those two only. So in the rolling function also you can use mod so that you get the values within that range only. But once you apply mod, then there is a chance of spurious hits again. Then again the algorithm may be going towards worst case time of mn. So it depends on you how you want to use it. See, if you know about hashing, you can define any hash function if you have the study on the data that you are using in hash function or hash table. So here also, if you have the study about the characters that you are using in the strings, then you can define your own hash function also. So the basic idea of Rabin-Karp is what? Use a hash code to avoid checking the pattern in the string. If the code is matching, then check it. That is the basic idea. That's all about Rabin-Karp.